Thank you for the opportunity to talk about the Edwards. We're going to mostly talk about the contributing zone and the importance of the contributing zone to the protecting the Edwards Aquifer. It hasn't been given the attention that it deserves, and so that's going to be the main focus of my presentation. I'm going to start off with a number of slides that just have text, so bear with me while we get through those, just so that we establish sort of the some of the fundamentals for the rest of the talk. So just a little bit of the background on the Edwards Aquifer Protection Plan. This, I think many people are familiar with this, but starting back in 2000, the citizens of San Antonio voted 1/8 of a cent of sales tax to buy sensitive properties over the Edwards, and it was mostly limited to Bexar County. This became and has become an extremely popular program in San Antonio, and it's been approved again in 2005, 2010, 2015 for considerable monies to protect these properties that protect the recharge to the Edwards. And as many of you are aware, the 1/8 of a cent sales tax that was approved by the citizens in 2015 will be running out in the next year or so. And there is debate over whether to continue use of that 1/8 of a cent to continue the EAPP or to divert that to other programs, some for VIA, some for education, and that will be apparently posed to the citizens this fall. So I'm going to talk about the technical issues behind this, and then we may get back to how the community may be addressing this. So there's a process in place to how to identify the properties for the EAPP. And those properties may be just a purchase of land, or it may be a purchase of a conservation easement that limits the amount of development on the land. The process is the same for both. First, there's a scientific evaluation team. They come up with the criteria on how to value these properties. That is forwarded to a conservation advisory board, who then relies on a land acquisition team to go out and visit the lands and see what is exactly there, and to come back with a report on that property, give it to the CAB, the Conservation Advisory Board, who takes into account all kinds of different information, not only scientific, but the cost of the land, the location of the land. And when they come up with a decision on the property, that's forwarded to the City Council of San Antonio, who makes the final decision, up or down, whether to get those properties into the program. So the scientific evaluation team is comprised of a number of scientific experts. I served on it over the last cycle, the 4th cycle. I presented to them a few times in the earlier cycles on some of the scientific studies that would be of interest and benefit to the CAB while they're making their decisions, and to the SET for coming up with a model. So the SET model is a weighting program. It's going to put greater weight on properties that have a greater value to be incorporated into the EAPP, and lower weight on those that are not going to protect the recharge to the Edwards as much. So you can imagine that there's a lot of information that goes into this, and it has been modified or refined over the 20 years. The land acquisition team, I believe, are comprised of folks at the Edwards Aquifer Authority. They are skilled scientists. They know how to visit lands, look for sensitive features, do a number of things like that. They come back with a recommendation or consideration of the property, and they report that to the CAB. And the CAB is comprised of a number of folks. Sarah has a seat on it, the EAA has a seat on it, SAWS has a seat on it, and others. They take into account, as I mentioned, all this information and eventually make a recommendation to City Council. So then City Council votes on whether to approve the CAB recommendation. Excuse me. And I don't follow this that closely, but I don't believe City Council has ever changed their decision from what was recommended by the CAB, but that I'm not certain of. So here we see where the properties are that have been brought into the EAPP. The purple area is the recharge zone. The area of consideration is that blue line that's above to the north of the recharge zone. Those are the areas that they have traditionally looked at to protect. These are the properties that have been protected. That big green blob just north of in northern Bexar County, north of San Antonio, is Camp Bullis. And you can see it's mostly outside of the recharge zone. The recharge zone is bordered by a light brown line and a dark brown line. And you can see most of these properties in green that are in the EAPP are in the recharge zone. There are a few properties that have been set aside for this program that are outside, but for the most part, they are all inside the recharge zone. So there's a spirited debate going on about the future of the EAPP, and some of the questions that have come up is, has the EAPP done all it was meant to do? Is there more that the EAPP should do? And I'm going to address that and come up with some, at least my perspective on what the answer should be. So here we're going to talk a little bit about how the aquifer and the contributing zone, recharge zone operate. Here's a map similar to what Annalisa put up. And what we have is the contributing zone, the recharge zone, and the confined zone. So how important is protecting the Edwards Aquifer contributing zone to protecting the quality of recharge of the Edwards Aquifer? So you need to be able to answer this if you're going to make a determination on whether to protect the contributing zone. So if the contributing zone is important to protecting the recharge of the Edwards, then if you aren't protecting the contributing zone, then you aren't protecting the Edwards Aquifer. Simple as that. So here is another very common image that we see. This is a cross section that shows the transition from up on the contributing zone through the recharge zone down into the artesian zone where the aquifer is confined. And the reason it's confined is the source of why there are so many flowing wells that led to the placement of San Antonio and all the major municipalities along the Balcones Fault Zone, which is this edge of the plateau of the Edwards Aquifer. So down here we see the lower unit, the Trinity Aquifer. We see the Edwards, and then we see shallower units, and you get this sort of complex geometry where older units that are deeper are higher in elevation than the Edwards, and it's across this transition, the Balcones Fault Zone, that occurs. So why is that? Well, over geologic time, you had this large area, the Edwards Plateau, that was uplifted, and that exposed the carbonate formations that are part of the Edwards Plateau. Okay, well, things are going a little slow here. Sorry. Okay, so we're going to talk about the conventional understanding of how the contributing zone works. So if you have a recharge, which is precipitation falling on the recharge zone, that gets into the subsurface, flows down gradient to the confined zone. Similarly, this is the conventional thought. If you have recharge that occurs or precipitation that occurs on the contributing zone, the contributing zone acts like a tin roof. Everything falls on the ground, flows down the creek beds till it gets to the recharge zone and then goes underground. So you can see that if you're looking at the contributing zone this way, it may not be quite as important as some others might think. So if you have recharge or precipitation occurring over both, you know, all the water goes underground in the recharge zone. That is the conventional conceptualization that's been embraced for decades, up to the last 1 or 2 decades. So there is now evidence that this is not how the contributing zone operates. And so I'm going to talk just briefly and give one example, and that's a Helotes Creek watershed. We could spend a lot of time talking about the wealth of evidence that supports this, but we'll keep it at the Helotes Creek watershed. So where is it? Here's Bear County. We have the Leon Creek watershed. And here's the Helotes Creek watershed as part of the Leon Creek watershed that goes down into Medina River watershed and eventually goes into the San Antonio. So they're all part and parcel. So just looking at it a little closer, we have some roads for helping us locate this. Here's I-10, 1604. Here's Highway 16, otherwise known as Bandera Road. And if you drive up 16, there are 3 gas stations here. This is right where you go into the hill country. It's flat here. You get into the hills up in this area. So you go through Helotes Creek watershed and then you come back out. But what's interesting is the faulting along here that is aligned along this color transition is so severe. You have hundreds of feet of offset in this fault that there really is no recharge zone in Helotes Creek watersheds, with the exception of this little parcel here. And the only reason you have this strange shaped thing is because that's a quarry. They've scraped away all the overlying Del Rio clay, exposed the Edwards. Other than that, in the Helotes Creek watershed, there is no Edwards, other than what's on the tops of some of the hills. So when water gets down in the base, it's already on the Trinity. The Edwards has been eroded throughout all these creeks in the Helotes Creek watershed. So about 8 or 10 years ago, maybe longer, I conducted a very short gain loss study, and it shows that water, you know, here's that 3 gas station areas down here, and pardon me, down here. And so if you go up the Helotes Creek watershed, the conditions then are similar to what is encountered just about all the time in Helotes Creek. You have a little bit of water up here. This is right at where Scenic Loop and the stop sign at Menchaca is, and the Madla Park is just off the edge. And you get more and more water. By the time you come down to Highway 16, there's no water in the creek. This is partway down. This is where there's always flowing water. This is flowing water at about 4 CFS. But if you go down here, this is standing on the bridge by Floor Country Store, just north of it, and Elf Hardware's behind you when you stand on the creek. This is what it looks like all the time. There is no flowing water. The only time there's water flowing in this creek is after a big rain event, and you can look at the USGS gauging station that's at the bridge, and you can see there are a few blips that co-align with big storms, but other than that, there is no water in that creek. So Helotes Creek is not an outlier. There are other examples that we could go into sometime, but let me say that there's considerable evidence that there's considerable recharge in the Edwards Aquifer. So just go back, I missed one point I wanted to say here. What you have here is all the recharge that is occurring in the contributing zone. All this water is going underground in the contributing zone before you get to the recharge zone. And you see this elsewhere. You see it at San Geronimo Creek, which is just off the west. You see it elsewhere in Leon Creek to the east. And this happens everywhere. So what it says is this is not a tin roof where water is just falling on the ground, going down the recharge zone, and then recharging the Edwards. And this water that goes into the Trinity, even though that's a unit underneath the Edwards, because of that faulting, the water that goes underground into the Trinity here goes directly into the Edwards. This is where the recharge of the Edwards comes from. So let me move ahead. So this conventional conceptualization has been refined. This is what we think happens. You get some flow down the creek that falls in the contributing zone, that does get to the recharge zone, but you also get a lot of infiltration in the contributing zone itself. So this is why you need to give protections to the contributing zone that you give to the recharge zone, because they're both equally important. So this is a refined conceptualization, and this is going to drive the story that I'm making here this evening. So if we look at this cross-section again, I recommend a revision to this, and that's where you have these subsurface channels of flow in the aquifer going from the contributing zone into the recharge zone and the artesian zone or confined zone. You have water going underground. We see that water is going, along Lotus Creek where it's dry, and it is going directly from the Trinity across this faulting into the Edwards. That's what happens there. That's what happens in many places. And so that is a refinement to this map that I would like to see, or to this figure I'd like to see incorporated. So once it gets into the ground, how does the water get from the contributing zone to the Edwards? So we see that we have this underground component when sometimes there's no water flowing in the creek beds. And so what you have is sort of a phenomena that's it's a little easier to explain up on the Edwards Plateau. This happens to be the Devil's River. But what you have is that rain that's falling over geologic time is slightly acidic. And the carbonate rocks that are part of the Edwards and the Trinity are susceptible to dissolution. So you get preferential flow that develops along the river channels up in the Devils. And so you see that you have much more flow in the subsurface. Flow is much easier down here than it is up on the rocks, because you have all this rainwater that is continuously funneled down to the bed of the river channel. And so it develops preferential flow paths along these riverbeds. And there's a lot of evidence to support this. Well, it varies a little bit when you get over to San Antonio, because you have not experienced all the uplift in San Antonio that you have out on the plateau. And there's been some outstanding work that was done by a couple fellows, Chalk Woodruff from Austin, and a guy, Abbott from California. They did this work back in the 70s and 80s, and it is outstanding. And they first identified that these conduits would form in the creeks and the river channels up on the plateau, but they would be in slightly different places down when you get off the plateau and off the edge. This is what we're seeing down here. We're seeing a lot of, this is why we have all this conduit flow in the Edwards Sound in San Antonio and off the contributing zone. But, for the areas where you have the rock exposed, and that would include Helotes Creek, what we see is that these preferential flow paths mimic the surface water drainage, and so you get fast water flow paths that align with these river channels. And there's considerable evidence to support this. So let's go back to the SET model. And the SET model, again, is that weighting model that the scientific evaluation team puts together in order to identify which properties are better set aside by the EAPP than others. And so during the first three sets, the properties of the contributing zone were given little weight. So when they were looking to buy properties or to put easements on properties, they did not give a lot of weight or serious consideration to properties on the contributing zone, because it was based on that traditional conceptualization that the contributing zone acts like a tin roof. Okay, but this changed in 2015. The fourth set took over, There were some new folks on it who took into consideration a lot of this recent work that's been done on the contributing zone, showing its importance. And so the set came up with a new weighting. And for the weighting for the contributing zone was based on three things: the watershed basin, which one? You know, is it the Medina? Is it the Guadalupe? Is it the Frio? The distance from the recharge zone up into the contributing zone, and the distance from the river channel. So it takes into account a lot of the science that I just discussed. So the distance from the river channel would be the distance from those preferential flow paths aligned with the channels. And then, you know, there's some concern that, you know, when you get too far up into the contributing zone, that it may not be as important. I would like to see this one give less weight, because I think that the upper reaches of the contributing zone could be just as important. And then the watershed basins, as you go west, you get farther away from Bexar County and San Antonio. You know, there's a lot of things that happen in between. So the basins closer to San Antonio should be weighted more than those farther away. So we do have an equation. There's always equations. This is the only one you're going to see, but it just takes the weight of those three things and gives some, you know, score to them, and then you give a total weight, and then this would be the composite weight given to properties up in the contributing zone. So there's concern that, you know, that if you open the door and you start protecting the contributing zone, that, you know, the people would try to get the entire contributing zone protected. This is a way to weight some of those properties higher than some of the others. So if you look at the basins out here, those closer to Bexar County are going to give higher weights. And so the set recommended to the EAPP that they put higher weight, greater weight on those properties going up to the contributing zone. The CAB has been reluctant to extend this weighting in the contributing zone. It's been a back and forth kind of debate. So it's an interesting dynamic. It's one that I agree with. So the technical advisors, which is the sets, they make the recommendations, but it's the policymakers who take those recommendations into consideration, and then they make their decision. Now, it may not be the decision the technical advisors like, but this is, I think, a healthy way things should go. And so as a member of the set, I have not been dissuaded from continuously making the recommendation to the CAB to go north. You know, they have other factors that they're taking into account, so they are moving a little slower than we'd like to see. So, you know, we have these properties here. These are where the properties have been protected. You know, so they're all along the recharge zone. This is the weighting that we've given the rivers, the river basins, and you can see I just highlighted the ones that have a weight of 8, 9, and 10. And if you look, there are those that are closer to Bexar County. So what this weighting says is, well, let's look north rather than buying properties out in Uvalde County and beyond in the recharge zone, that these properties in the contributing zone closer to Bexar County should be given greater consideration, greater weight. And when you put the scores together, maybe start looking up here rather than out in this area. So back, this is the end of my discussion, answering these questions. So, you know, there's a spirited debate on the EAPP. Has the EAPP done all it was meant to do? My answer is no. Is there more that the EAPP should do? My answer is yes. And it's to go north, not west, and look at those properties in the contributing zone. So if you need contact information, although I've retired as a full-time employee at Southwest Research, I'm working part-time, and I'm utterly failing as a retiree. I keep working more and more each week, so feel free to contact me.